Hi, my name is Claudia Colmo, and I recently graduated from CETA Computation Architecture this year. And I'm going to talk about today about my thesis presentation, my thesis project, 3D printed bio-hydrid structures. And it's a research that investigates mycelium as a living remediator for contaminated soil. So for those who don't know mycelium, so it is the underground network, and it's the vegetative part of the mushroom. The mushroom itself, it's fruiting body. Sorry, yeah. And the organism, so the organism is usually, what's happening? Yeah, it's a bit confusing. Yeah. So the organism is usually killed to form discretized components into structures, and this is followed by a really complex process of fabrication. But does it work? Can you hear me? Okay, whatever. So a very complex process of fabrication which needs absolutely sterility. And but in my case, I was more interested to maintain the organism alive and use its natural abilities to deconstruct contamination and purify soil. And that's so the design concept is called micro-restoration. So soil contamination is a huge challenge in our society, and here is the example of Copenhagen area and the ranked area of contaminated soil. The state of the art presents a vast repertoire of remediation technologies. However, these remediations are, have quite a lot of limitation in their application in terms of practicality and cost. So the fact that we can combine a plurality of mycelium species for a synergetic effect to decontaminate a plurality of toxin gives opportunities to develop customized mycological landscapes. So far it's very overwhelming, the amount of research in micro-restoration. However, there is a huge gap in its application. The technology up to date is quite rudimental, and there is no full-scale application matrices. So this gap between academic research and in industry actually opens up incredible opportunities for us architects to start speculate. And so my research tries to answer the question of how this micro-restoration concept can be architecturally expressed. So the site that I chosen for my project is the Docken, which is in the, everybody knows, I guess, it's located in the heart of Copenhagen. And I was able to acquire real data of contamination in the site, and the agent of contamination are mostly are classified from hydrocarbons and heavy metals. So therefore, this suggests that the best combination of mycelium species for this synergetic decontamination is the Pleurotus striatus and the Tremetes versicolor. So I started with a speculative design proposition that it is articulated into a program of a restless labyrinth. So the labyrinth builds a landscape that is in continuous evolution and mutation, and is based on the concept of stretching materialities into structures. So the system changes periodically. For each iteration of the labyrinth, the soil is utilized as the bulk material for construction. Then additive manufacturing is used as to create the formwork for the 3D printed system. And then in the system, it is insert a combination of cellulose substrate with mycelium. After the system is exploited and the soil is decontaminated, it is put back into place. So the labyrinth distribution is informed by the underground contamination in terms of position and heights. And considering the high amount of contamination in the Docken, the labyrinth has a lifespan of 1.5 years, and each iteration has 6 weeks of life. Yeah. So the labyrinth is considered as a standing wave where there is a continuous flow of matter and energy while maintaining its architectural identity. So with the first configuration of the labyrinth, the excavation area gradually turned into wetlands. And thanks to an underground water system composed of water reservoirs. And even though the main protagonist of the landscape is the labyrinth, there are complementary features that actually use the same architectural language but are exploited in different ways across the landscape. And classical architecture perspective principles are incorporated into the landscape to draw cutting views while conferring a sense of archaeological ruins to the site. And the labyrinth, I've imagined the labyrinth as that embrace this concept of the picturesque landscape paintings in which the architecture and the landscape are meant to be in combination with each other, and the human intervention is not meant to brutalize, but more to accompany the landscape, and therefore the aim is to establish this symbiosis between nature and the architecture. So the restless labyrinth is the combination of these 3D printed bio-hybrid structures, and those are generated through a customized differential growth algorithm. And the curves produced present the 3D printed path for material deposition. And this method allows to have a wall composed by discrete elements while giving the illusion of a continuous structure. So these discrete elements actually facilitate the manufacturing process as well as the demolition, and it gives the possibility of a partial reconstruction between iterations. The technology I've used to construct the labyrinth is a customized axial mobile 3D printer, and the construction of the labyrinth is possible by a collaborative fabrication of 2 robots. The construction is arranged to be fragmented day by day with a layer by layer deposition of 40 centimeters per day. And after the initialization of the first 40 centimeter of material deposition, there is the immediate inoculation of the structure. So this method is applied every day until the construction is completed and allows the material to dry and assures a consistency in fabrication. So the overall landscape is the result of the combination of the 3D printed structure, which serve as a vessel and as a boundary to contain and protect the mycelium. The labyrinth presents a living demonstration of how biology can be functionally integrated in an architectural context. And mycelium, even though it has the main role as the remediator of the landscape, the fruiting body, so the mushroom itself, is very important because it's the tool through which the system recalls the fauna and the flora. So to establish the plausibility and test the feasibility of this proposition, so about this hypothesis, I tested, I exploited some empirical investigations, and with a focus of direct to material composition, biocompatibility, and this to set symbiosis, and at the end there is a synthesis of 2 growth experiments. So the raw material for construction, I've been directly got it from the Docken, so in site, and then in which was visible the high contamination level of hydrocarbons in the soil. So I have extracted the soil, I filtered it, and then I refined it, and I added bioadditives to give this, and it gives this kind of muddy appearance. And the material grading was by adding bioadditive is fundamental because it serves to establish biocompatibility between the mycelium and the structure and to set symbiosis, and while producing a extrudable composite for 3D printing. So I've developed 2 recipes, recipe A in this case and recipe B. in which is embedded mycelium spawns. So the fabrication setup is UR5 with 1 liter syringe capacity, in which the material is pushed and then it's extruded by a customized extruder. And I've established control parameters for layer by layer deposition and for the stringing method to enhance porosity within the structure. So by comparing the tests, I was able to combine the parameters for an optimal production. And the material and 3D print investigation are then, I merged these two investigations and I produced 2 growth prototype experiments. So so the 2 sections that I produce, I have the same type of geometry of the labyrinth. The geometry followed the concept of stretching materialities and increase the connectivity between the mycelium and the structure, and this curvature actually assures stability while 3D printing. So these 2 prototypes, even though they look the same, but they actually have different inoculation method. They both use the same strain of mycelium, but one is inoculated internally, and the other, the inoculation method is through fabrication, so through 3D printing. So the prototypes were grown in lab condition in a glass tank. So for the first prototype, the double skin section prototype, I've tested the plausibility to print with embedded mycelium in internal skin, and then I've inserted some lignocellulose substrate internally. However, during the 30 days of growth, there was no sign of, no sign of mycelium growth. For the 1 skin prototype, I have used recipe A, and then inoculated internally with the Pleurotus ostriatus strains without any sterilization. And after the inoculation, I was already able to see, after 5 days, the first signs of growth. And then after 15 days, it was quickly spread onto the surface, and biocompatibility was established through the appearance of the first fruiting bodies on the section. So while the first generation of mushrooms started to decay, there was a second generation of mushroom that started to grow, and they would look way healthier in a way, and with the appearance of these large caps of fruiting bodies. And here there are some pictures of close-up photos of the primordial phase of the mushroom evolution. They look, it looks kind of like an underwater reef. But the interesting part is that the mycelium covered the whole print and became part of the materiality of the structure, and create this hydrophobic skin that protected the print from water infiltrations. So here there are some more photos about the first generation of mushroom to the second one with this, with the these really large cups in which the spawns are located, and then we surprised there was even a 3rd generation of mushroom. So the experiment was quite successful with the appearance of 3 generations of mushrooms. However, the exploration moves to investigate more the relationship between the system and its surrounding, and the deep time aspect of the system. So the system is all about setting boundaries for the fungi to operate. However, I experienced that designing with nature is quite challenging and implies that there is always an uncontrolled aspect of the designing, let's say. So even though the mycelium spreads into the ground, it kind of, the spawns are pulled away from the wind. So I speculate that the effects of the system can be found in the site itself, but also in the surrounding areas. So moreover, there is the ecological aspect that the system promotes. So from the high contaminated soil, that is considered an extreme environment where that supports just few species. So in this case, the two mushrooms, the two species of mushroom, and they are considered the pioneer species, but then has the decontamination take over. This opens up windows to other type of colonization and biodiversity, and over time, probably the appearance of a new ecological system. So, and this is because the mycelium has spreaded in from the scaffold to the soil, creating this beautiful network that purifies the soil. So why not speculate that in the Docken, maybe in a certain time of period, there would be new communities taking over and creating a new ecosystem biodiversity. So overall, the research presents a living demonstration of a biologically integrated system that is functional and performative, but also creates opportunities to integrate different types of occupants and at the same time be ecological positive. Thank you. That was all.